We're going to continue with the the three conveyors practical application, and we're no longer introducing new ideas, but as I said in the previous lecture, we're kind of fattening up the code with practical stuff. And really all we're doing now is going over the operation. Since we don't have three live conveyors sitting there to put objects on and watch it run, we pretty much have to execute the code virtually and then watch the change in status of the bits that represent the actions that take place, like conveyors running, etc. So let's continue looking at our code. Here we are in the final phases of the challenge in the last section of RSLogix 5000 or RS5000 beginner, the very basics, the very introductory. The next step is to edit your rungs of logic as shown on roughly page 247, 248, something like that. So I'm going to pause, make the changes, and then come back. So you will see the changes instantly, but I'm not going to make you watch me drag instructions around on the screen. Just as a reminder though, looking at our routines, we were looking at production. That's what we've been looking at, the production routine. We have the lubrication routine. You remember this code from previous labs. And then we have the main routine, which is just the system enabled, and then the JSRs to these three routines down the bottom. The one that we're going to be focusing on now is the conveyors routine. And right now, if the system is enabled, if something is blocking the photo eye at the beginning of those three conveyors, the conveyor motors run. So this is where we're going to be doing our edits. Okay, we're back now with our three conveyor motor rungs, if you will. In the manual, we have the logical statement of what you see in front of you. Let's read what conveyor 1 says. Conveyor 1 runs if. So this bit is set on in memory if, of course, we're going to leave out system enabled. We just assume that the system is enabled. If photo eye 1 is blocked. If the photo eye at the entrance of conveyor 1 is blocked, we want the conveyor to run unless the conveyor is full. Conveyor 1 count has to be not done. If it's full, if it's done, then this will be false and the motor won't run. Also, if the photo eye is blocked and conveyor 1 is full, not full, full. So this will be true if it's not full, this will be true if it's full. However, if it's full, conveyor 2 has to be running, otherwise we're not going to run conveyor 1. Remember, we're not going to jam up cartons at the entrance of conveyor 2. So looking through that again, the primary permissive or condition for motor conveyor 1 is photo eye conveyor 1 entrance has to be blocked to turn on conveyor 1 motor. However, if it's not full, then we just turn on conveyor 1. If it is full, we can't run conveyor 1 unless conveyor 2 is also running. This instruction is looking at the result of the logic in this rung. If this rung is true and conveyor 2 is running, then that will be true. If this is true, then we can run conveyor 1 regardless, whether it's full or not full. We can run conveyor 1 if conveyor 2 is running, which means that the cartons have some place to go. Obviously, conveyor 2 is not going to be running if it's full and conveyor 3 is not running. So if you follow the same logic and drop down 1, we now have the full state of conveyor 1 to consider. Now, this bit right here is kind of a logical pivot. It depends on whether you want to fill up all three conveyors one carton at a time, or you want to just buffer the first of the three conveyors. You see, we're not going to run conveyor 2 unless conveyor 1 is full, which means that we have to completely fill up 1 before we run 2. That's in series here. That is ANDed with photo eye being blocked at conveyor 2 entrance. Notice this does not consider that anything to do with photo I1. If there's a carton blocking the entrance of photo I2, so you have to ask yourself, how did it get there? It didn't just show up out of the blue from nowhere. Now, in the rung 0, photo I conveyor 1 entrance, we don't know where those cartons are coming from. Our system doesn't care. It probably rolls down a gravity conveyor and comes to rest against the nose of conveyor 1, the entrance of conveyor 1. All the more reason to have a debounce timer, because if that carton rolls down a gravity conveyor and bounces a little, it could bobble in and out of that photo eye. We probably would tidy up this code right here with a debounce timer. Now, we have a debounce timer to handle the production counts, but we don't have here to keep the motor from pulsing. We'll just take it as it is, though. Remember, we want to keep this simple. You can make it more complicated when we're done with this project, then by all means, you keep playing with it to your heart's content. We understand this, that a carton blocking photo eye at the entrance of conveyor 2 implies indirectly that conveyor 1 is running, because conveyor 1 wouldn't run unless it was empty or conveyor 2 is running. But we're talking about getting conveyor 2 running. If conveyor 1 is running, it'll be because the motor of conveyor 2 is running. So in the case where this is full, conveyor 1's not going to run until conveyor 2 runs. But anyway, let's move on. There's a carton blocking the entrance of conveyor 2 and conveyor 1 is full. Now if it's not full, then we don't want to take any off of conveyor 1. Now if this photo eye is being blocked, I don't know how conveyor 1 could not be full, but we put all of the permissives and conditions in there to make it a clear logical statement. And if conveyor 2 is not done, meaning the count's not done, meaning it's not full, then we run conveyor 2 to pull a carton on. And of course, the minute it clears, it stops. However, if conveyor 2 is full and conveyor 3 is running, which means there is some place for the cartons on conveyor 2 to go if we run conveyor 2 when it's full to pull another carton onto conveyor 2. Likewise, when we get down here, if conveyor 2 is running and runs a carton up into the entrance of photo I for conveyor 3 at the entrance, and conveyor 2 is full and 3 is not full, then we run motor conveyor 3. Otherwise, if conveyor 3 is full, and this is false, if we have a downstream request, that would basically be the same as this condition of motor 3 running. In other words, this means there's someplace to go. If downstream they're calling for a carton, then that means that their system is running ready to pull the carton off of 3 onto their section of production. So that's how that code works. And you can read the logical statements, including the parentheses, the and the nor and the nots, on roughly page 247, 248 or so. Then I had you add a RSLogix to your production routine. Basically, if you toggle this bit, and you have to toggle it from your keyboard, then it will reset all of these timers. I'm sorry, all of these counters. Now, one thing I just noticed here, because when I toggle this, it should have went back off, and I'm looking, then I say, well, Tim, you're not online. So I go to communications, who active. So I forgot to download after I made all those changes, which didn't matter until this minute. So you see what happens with a reset. When we go back to the run mode, watch reset conveyor counts. See, it goes back off. Toggle it on. You never even really see it go on. It's self-extinguishing. So the next scan, when this is true, reset, 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 unlatch, or remember there's a true execution only for the unlatch, and that's to set reset conveyor counts off. So this is just another little way to be able to toggle a bit on and have it go back off by itself after it's completed what you needed. explain how this rung works and how to execute it. I just did that. Although we might not do this in the field, we are going to move the RTOs from the conveyor routine to the lubrication routine to make the logic more readable for the beginner. Now, I already did that. If we go back to conveyors here, you see they were gone when we started this discussion because I had already moved them. So if you remember, right after this, you turn this on and then we did the RTO. Well, if this is on, then that means this rung is true. And the true state passes through that instruction to the RTO. If we take and examine this bit on in memory, the motor conveyor, we can transfer it to the RTO. And I did that for the 3 lube schedules. Now, the next thing, and I'm just making this up as I go. I mean, I'm talking about when I write the manual, I sit down and I just start developing something. And then I'm always thinking, well, now what can we do next to show some other facet or feature to enhance your learning experience? So I looked at this as well. Edit your lubrication routine to look as follows, which you did, and then, and you're looking at it right here, can you think of any way that you could combine some of the lubrication logic, that is, combining the first 2 rungs into one? And I show you how to do this. I'm going to do that right here. And basically, I am going to move these 2 instructions in front here because, see, this is conveyor 1 loop schedule, conveyor 1 loop schedule done. I can double click here, click there, and then control click, and I can drag this down to here. See? Click there, delete. And then double click here, select that with the shift key held down. So you got them both selected, and drag them down to the instruction me at the head of the rung. Delete. Double click, select, shift select. So you got them both selected. Left mouse button down, drag it over to this me and release. Select this rung, delete, finalize all edits. And that should be good. What might occur occasionally to render the lube cycle short? Well, we did mention that earlier. If we happen to stop the system, you know, hit a stop button like stop system, it would stop everything. The rung would, see, these motors would go off. You know, we would just lose where we're at in our pulse because the rung would go false. So we want to bypass the motor. So double click to put in the edit mode. Select, branch around. So if perchance the motor were to turn off, we want to keep it on as long as we have the lube pulse going on. Take the conveyor 1 lube pulse. If this timer is running and somehow the motor gets turned off, the timer timing pulse ORed around the true-if-on on the motor bit will keep the rung true until the timer times out, and then the rung goes false. We would do that on each of our rungs. Grab the tag, drag it over here, double click, select, branch around, true-if-on, and drag conveyor 3 loop pulse over. Finalize all edits. And voila. There you go. And we can see the whole thing on one page. As a matter of fact, we can geezer it up. Whoop, too much. There you go. That's as far as we can geezer up for you to see everything. Now, there isn't much more that you could do to, well, you could combine the reset. We could make the 3 rungs just a little bit more convoluted. You see this done bit right here? We could branch around here. Branch around and move the reset and the done bit right here. But I don't know that it would make the code any more readable. However, it does make it more conclusive. So just for grins, let's do one. Put that in the edit mode, click on that one, pick a branch around. Now I could make a fool out of myself here and this not work. I'm going to, I don't like to see it wrapped around like that. It's difficult to look at. So I'm going to grab this and then shift, select, and then drag this up to here. Remember, I'm not moving it. I'm just taking a copy because that rung's not in edit mode. Okay, it would look something like that. Okay, so then I'm going to render this rung not workable, I'm going to do this. This is a very easy way to cheat. So I think you can see what I've done there. I'll explain it if you can't. So this says if the pulse is not done and it is done, then reset. Well, you know, they can't both be true, so we'll never reset lube 1. So let's check it out here. To run motor 1, we'll go to conveyors and we'll turn on the entrance to, oh, we need system enabled. And we need conveyor 1 count is done. That's probably because we have 0 in here for preset. We never put presets. So I'm going to go back and turn off that photo eye so this doesn't take off when I change this. Let's say 3 is full for all of these. Okay, and now back to conveyors. See, they are all ready to go. As soon as we see the entrance photo eye, conveyor 1 is running. If we go to lubrication, we've got a 12-second timeout, and when that's done, you see the pulse. Okay, and when this pulse was done, it reset this timer. See, that worked. So we'll let it go again. Watch, this gets 12 seconds. We have a 2.5 second pulse on the lube, and then it resets itself. And this is just going to keep running. Now let's say we turn off motor 1 during this 2.5 seconds. Oh, I was a little slow. See, it kept on going. Now let's do that again. So there's the motor 1 is running. We got to get the loop schedule going, and then we're going to turn off this motor by way of the photo eye once we're in this 2.5 seconds. So I turned it off, see, but it keeps going. So the motor disappeared, it went off, but the timing pulse from this timer, not this one, this timer, keeps it going. I'm going to delete this rung. Now I think I'll leave this rung as is and leave these two as they are so you can see the difference. In case you want to study it, sit here and you can change your logic because this isn't in your manual. Okay? Every time I go through these things, I see more, think of more. You know, there's more things I'd like to show, but there's just a limited amount of time. You just can't keep writing page after page on the same subject to cover every possible iteration. We edited our code to handle the timer timing bit to keep it going. Do not make those edits to combine each of the two lube rungs into one unless you are comfortable with the logic. This is your machine. You know, at this point, we're kind of running fast and loose. So somewhere in this last section, when we were doing part 5 of the challenge, we got a little looser and I started doing things different. And at this point, you're able to, more than capable of making changes and doing it any way you want. Okay, save your project as challenge 1 final. So this would be the final state of your project. And there you are done with the lab exercises of this manual. However, we do have a couple pages to go talking about testing this challenge. Challenge 1 continued, part 5, testing challenge 1. On approximately page 252, 253, thereabouts. If you do not execute this sequence correctly, you will have to start over from the first step. I'm going to walk you through it. I won't do a perfect job. because typically what happens is I get distracted by some point that I want to make, and then I don't necessarily get back smoothly to the sequence. Understand this: to simulate a part arriving at the entrance to a conveyor, you turn the photo eye to the on state, and it stays in that state until the conveyor motor energizes and pulls the part forward. When the conveyor has moved the part forward, it eventually clears the photo eye and the photo eye reverts to the off state. This means that you have to flip the switch or hold down the push button that represents the photo eye. You're going to have to turn it on and leave it on until you see the motor running. Then you can flip it back off or release the push button. In the manual, I show the 3 conveyors, conveyor 1, 2, and 3, with local 1O, data 1, 2, and 3 for the motors. And I have photo eyes 1, 2, 3, and 4, local 1I for input, data 1, 2, 3, 4. At this point in the sequence, the counter for that conveyor will increment as having accepted it. That is a continuation of my previous statement about holding down the push button or leaving the switch on that represents the photo eye, and leave it on until you see the motor running, and then you can flip it back off, that is, release the push button. At this point, the counter for that conveyor will increment as having accepted it. If the part is coming off of an upstream conveyor, that event will also need to decrement the counter for the conveyor from whence the part came. I don't know if you want to say upstream there, downstream, but if a part is leaving one conveyor and going upstream to another conveyor, then you count it on to the next one and count it off the one that it was on. We'll go over our I/O here real quickly. In the manual, it shows 2 columns, inputs and outputs. Input 0 through 5, system start push button, photo eye conveyor 1 entrance, photo eye conveyor 2 entrance, photo eye conveyor 3 entrance, photo eye conveyor 3 exit. And then input 5 we may or may not be using, depending on whether or not you used it for downstream request. I think I had you do that in the manual, but it wasn't necessary. You could always toggle it, right from your keyboard, because we are really simulating this. And then, of course, for outputs, output 0 isn't really used, but output 1, 2, and 3 are motors 1, 2, and 3. So the test sequence: toggle the reset conveyors bit to clear the counters. If we go to production, and of course they are all, there's 3 in conveyor 1 there. So we'll toggle this, and that clears all of the conveyors. Lower the preset on all of the debounce Pt1 instructions to reduce your waiting time, unless you would rather watch them accumulate for more fun, meaning that you have more time to think the longer you make these timers. Lower the presets on the counter data types to 3 for conveyor 1 and 2. The preset for conveyor 3 should be set at 1. That means that our preset for conveyor 3 set at 1 is that we're not going to do a complete buffer on conveyor 3. Because remember, you can buffer any number that you want from 1 to 3. 3 will fit on the conveyor, and you can have them pass through or buffer, and you can buffer 2 or 3. Open all the routines with exception of lubrication. Down here I have lubrication open. I'm going to remove that, close that routine. So I have main routine, conveyors, and production. That doesn't mean you can't have lubrication down there. It's not going to hurt a thing. In case, I'm going to put it back down there. So it's main routine, conveyors, production, and lubrication. This down here has nothing to do with anything but display. It has nothing to do with the controller. This is just for you. Open all the routines with exception of lubrication. Arrange your display wide enough to accommodate any of the 3 routines in the window without the rungs wrapping around, and tall enough to accommodate all the rungs in any of the 3 routines. I think we're okay without moving around these menus up here like we've done in the past. Let's look. Main routine, conveyors, we can go a little bigger there. Production, I don't think we can go any bigger there. We'll give it a try. Oh, went too many. As a matter of fact, we'll just stretch this out a little wider here and see if we can go bigger. Yep, did not wrap around. Conveyors, we can go bigger. Lubrication, we can go bigger. So there, we have everything up nice and big. Now, if you're using a mobile app, you're still going to have a visual challenge to see all of this on your small screen. But give it a whirl anyway. Otherwise, use Sling or whatever that feature is on the smartphones. I know it's on my Kindle Fire HDX. Slingshot, I can't think of the name right now, but you can take, and if you have a wireless TV, you can view it on your wireless TV. Some of this you may have to view on a bigger screen than your mobile app. For the sake of expediency, we are not going to spell out each tag name every instance where we refer to them. It will be Photo I1 instead of PE Conveyor 1 entrance. Okay, switch PE1 on and leave it on, and select the conveyor's logic. Well, you might want to have a little piece of paper off to the side that duplicates the list on the previous page that showed input 0 through 5, output 0 through 3, and have them written out for easy reference. Switch on PE1, which is input 1, and leave it on. Now I'm going to go to conveyors. There's PE1, flip it on, leave it on. Okay, the conveyor's running. Now we can leave it in this state because we really don't know how long the conveyor is or how long the carton is. Theoretically, if this carton was a foot long and the conveyor is traveling at 1 inch a minute, it's going to take 12 minutes to get the carton on the conveyor. Or the other way around, the conveyor is traveling at 1 inch a second and the carton is 10 foot long. As you can see, the conveyors themselves are virtual and they're fictitious. They aren't confined to any length or width or speed for this logic. Conveyor 1 is running. If we go to lubrication, what we're going to see is it keeps timing out and pulsing grease every 12 seconds. And we don't really need to ever look at this again. We know this works, so it's just working in the background. If we go to production, we see that the photo eye is still blocking conveyor 1. The debounce timer is timed out, and now it's just waiting to clear photo I1 to count up 1. Are any of the conveyors running? Yes. Which? Conveyor 1. If you had not left PE1 on for an interval greater than the debounce, would the above answers be different? Yes, they would. Nothing would be running. Switch PE off and leave it off. Okay? So we just cleared the photo eye. See, we counted up 1. And you see that the conveyors aren't running. So at this point, if you wanted to flip your pages back a half a dozen or so to the diagram where we had steps 1 through 8, this would be step 2. Carton is on conveyor 1 and has cleared the photo eye. So you might want to put a slip of paper in your manual for easy return to that diagram. If you need that. If you don't, well, don't worry about it. Okay, we were on page 253, 254. We switched PE1 off and we left it off. Did conveyor 1 counter increment to 1 when PE went to the off state? Yes, it did. Select the conveyor logic. Are any conveyors running? No. While observing both the production and conveyor routines at appropriate moments, switching back and forth, switch PE on. Check conveyors running and then switch PE1 off and check the count increment. So we're looking at the conveyors now, so we switch PE on again. Conveyors are running. We go over to production and we go off with a photo eye. See, we count up with 2. Go back to conveyors and the conveyor's not running. Did any conveyors run? Yes. Which? Conveyor 1. Did any conveyors run? Yes. Which? Conveyor 1. Did conveyor 1 counter increment to 2 when PE went to the off state? Yes, it did. So far, with each on state of photo I1, the conveyor should have been running, and when photo I1 went off, the conveyor stops and the counter increments. If this is not so, either the logic is not correct or the inputs were not sequenced correctly, or you missed something that did occur. Right now, we'll go to production. We have a count of 2 on conveyor 1, nothing on any of the rest of them. And none of the motors are running. And all the photo eyes are off. Switch Pt1 on and leave it on. And select the conveyor's logic. We're already there, so we flip it on. Okay, conveyor 1 is running. Go to production. Conveyor 1 is running. Switch P off and leave it off. Did any conveyors continue to run? No. Did the conveyor number 1 counter increment to 3? Yes, it did. Are any of the conveyors full? Counter done bit is on. We would go to conveyors. Now this is one place that we can do it. I mean, if we go to production, we can see the done bit is on here for conveyor 1. We can see it there, or we can go here and we can see that the conveyor 1 count done bit is on. How did you decide whether or not a conveyor was full? Well, that were decided when you designed it or just now when you looked at it. I guess the answer is both the same. You are counting cartons onto the conveyor and you set the full count at 3. When the counter was done, it's full. In this next action, you're going to simulate a part arriving at the entrance of conveyor 1 by flipping on the switch that represents photo I1. And since conveyor 1 is full, conveyor 2 will have to energize to pull the part exiting conveyor 1 fully onto conveyor 2, blocking photo I2 and running until both photo I1 and photo I2 are clear. Before we go to the next paragraph here, think of this. If conveyor 1 is full, which it is right now, with 3 cartons, nothing's going to move until another carton arrives at the entrance of conveyor 1, which means that you're going to turn on input 1 first. That should energize conveyor 1 because conveyor 2 is not full. And when the carton gets the furthest downstream carton, the lead carton, gets to conveyor 2, it should turn that photo eye on and start up 2. You're going to turn them on, photo eye 1 on, and then photo eye 2 on, but photo eye 1 will clear first. So photo eye 1 on, photo eye 2 on, photo eye 1 off, photo eye 2 off. On, off, off. So they go on 1, 2, and then they go off 1, 2. Because the carton got here first, this one will go off first. Okay. We will operate the switches in this order: PE1 on, PE2 on, PE1 off, and then PE2 off. This simulates the parts blocking and clearing the photo eyes in that order: PE1, then PE2, then not PE1, and then not PE2. Think this through completely before you start. Visualize what you are doing. If you cannot visualize the process in your head without actually looking at it while you're programming, you will never make it as a controls engineer or a control system programmer. Now, you might work as a junior controls engineer and stay at the beginning level in a cubicle and always be assisting somebody out on the shop floor and maintaining a mediocre existence but never growing. So if you don't visualize well, start practicing right now. Pick anything. Close your eyes and then picture all the details of it. Just keep exercising your imagination until it's a usable tool. If you cannot visualize the process with your eyes closed, you will not be able to automate it. If you have difficulty with this, start practicing now and continue practicing until you are proficient. Look over a complicated mechanical device. Turn your gaze away from it and imagine what you have seen. Keep doing that until you can visualize it completely. The next level of visualization is being able to walk around it and see it all in your mind, even miles away. Almost any process that I've ever worked on, for instance, right now it pops into my head, one of the ones I worked on last year on Lake Pontchartrain outside of New Orleans. It was at I won't say the name of the company because it's a military contract, but they do marine and land vehicles. And I was working on the automated gantry welders for the U.S. Navy hovercraft. They call it ship-to-shore connector. Massive, massive labyrinth of welded aluminum for the hull, and then it's got a bladder that runs around the outside, got 2 jet engines on it. It's got pilot houses, it can haul tanks, Humvees, you name it. Right now in my mind, I can recall almost every single detail about that process. I mean, I can walk around, I can look at even irrelevant things like because it's welding, it's automated gas welding, there are welder's curtains around the sides of it on the gantry, so if you're standing to the side, you don't get the arc flash in your eyes. I can see those, I can see the scratches, I can see how poorly that they didn't really lay flat, it's plastic. I can see and this was near the water, so there are always spiders. I can see the spider webs, I can see the little crabs run across the floor. I mean, when you do this work long enough, you intently look at something. Now you have to look at it to remember it. You can't just throw your eyes in that direction and then close your eyes and remember all the details. You have to look at the details. So look it over good and then practice visualizing. Okay, this is a good spot to slow down and practice visualizing the process. You've got these 3 conveyors, you have photo eyes. You need to go back to that prior page that showed the 1 through 8 steps, and then come back here. That's fine. This is your learning process. You can pause the video and go do that and come back. Okay, now we want to switch on Pt1 and switch on Pt2. So on with Pt1, on with Pt2. Now because conveyor 1 count was full, that turned on conveyor 2. If this had not been full, there's no reason for conveyor 2 to come on. Just conveyor 1 to pull on a carton until it gets full, but it was full. So it turned on conveyor 2. If we go to production, we see that both of these are in the debounced state, but nothing has changed here counts-wise. So we go back to conveyors. Are any of the conveyors running? Yes. Switch. Conveyor 1, conveyor 2. Switch PE1 off and then PE2. Now I'll go to production. So we're going to switch off PE1. See it counted up. Switch off PE2. And notice that you may have seen this go to 4 before this counted up and then counted it back down to 3. That's fine. So we have 3 on conveyor 1, it's still full, and 1 on conveyor 2. What are the values? Well, are any of the conveyors running? Well, let's go back. They shouldn't be, no. Which? None. What are the values in conveyor 1 and conveyor 2 accumulates? CE1 is 3, CE2 is 1. See, 3 accumulate, 1. Repeat the previous sequence, PE1 on, PE2 on. Look at the conveyor logic to note what is running, and then PE1 off, PE2 off. Okay, so we repeat these 2 steps. PE1 on, timed out, PE2 on, timed out, then PE1 off, PE2 off. Okay, see now we still have 3 because a new one came to the entrance of conveyor 1. So we have 3 in conveyor 1 and 2 on conveyor 2. I forgot to go look at the motors, but we know they ran. Otherwise, well, we know that they ran because as long as conveyor 1 count is on and we're running conveyor 2. Now notice what's interesting here. Let's do this again. and I'm probably going out of sequence. Oh well, let's turn on conveyor 1. Notice a carton arrives at conveyor 1 at the entrance, but does conveyor 1 come on? No. Why? Because there's no place for the cartons to go. It's full, so it sits there. At this point, we have conveyor 1 full and conveyor 2 full. Look at the conveyor 1 count done, conveyor 2 count done. But let's back up a minute, and I'm going to artificially change the conveyor 2 count to 1. So there's only 1 on conveyor 2 and 3 on conveyor 1 that is full. Go back to conveyors here. Conveyor 1 is full, but conveyor 2 is not full. Now there is a problem with this code. When I create this kind of stuff, I just go at it like I would sitting at my desk. Later on I find something that's not quite what I wanted. I edit the code to match. When I discovered that, I decided to leave it as it was and continue on and then discuss the problems with this code. In the manual, it went like this. We had you turn on photo I1 and then turn on photo I2. Now notice that the motor didn't start running. When I turn on photo I2, then both motors run. So there's a little fly in the ointment there. We'll discuss that later, but we'll continue for right now so we match what we have in the manual. We turned them on, now let's turn them off. 1 first, then 2. Then we went to production, and I ask you, what are the values for conveyor 1, conveyor 2 accumulates? Repeat the above steps, look at the conveyor logic to note what is running, and then PE1 off, PE2 off. So we do it again, 1 on, 2 on, and then 1 off, 2 off. Now we have 3 and 3. So now we have 6 cartons, 3 on 1, 3 on 2. Before we go to the next step, if conveyor 1 and conveyor 2 are full, and another part arrives at the entrance of conveyor 1, where will the parts on conveyor 1 go and the parts on conveyor 2 as well? Conveyor 3 has a preset of 1. Once that is reached, conveyor 3 does not run unless the manufacturing area is calling for parts or a carton downstream. To pass a carton onto conveyor 1, we need to transfer a carton onto conveyor 2 and transfer a carton onto conveyor 3. For this to function correctly, the controller should see PE1 on, PE2 on, PE3 on to simulate the train of cartons moving across the 3 conveyors. Now we're going to change this in a bit, but for right now we'll leave this as is. So I'll switch PE1, 2, and 3 on in that order and leave them on and look at the logic. 1, 2, and 3. So we look at conveyors and we see all 3 conveyors are running. Now that's because there's not 1 on conveyor 3, otherwise it would be done and we'd wait for a downstream request. Are any conveyors running? Yes. Why? Well, because all 3 photo eyes are blocked and conveyor 3 is not full. Really, it's because conveyor 3 is not full. If it were full, then we couldn't run 3. If we don't run 3, we couldn't run 2, and if we don't run 2, we couldn't run 1. Did the conveyors energize before or after you simulated the PEs being blocked by the cartons? You could get so distracted with the logic that you are not visualizing the process. The photo eyes will not see cartons unless they are moving. Turn off the photo eyes in reverse order that you turn them on. 3, then 2, then 1. So 3, then 2, then 1. Are any conveyors running? No. Why? Well, because now the photo eyes are blocked, there's no cartons to move. Are any of the conveyors full? We can see the conveyor 1 and 2 is full. Let's go to production, and we see that conveyor 3 is full. See, the done bit is on because we have a cum of 1, preset of 1, it's done. So first, let's have another carton arrive at the entrance of conveyor 1 without a downstream request. Make sure that the downstream request bit is in the off state. Conveyor, that's off. Right there, downstream request. Let's have another carton arrive at the entrance of conveyor 1 without a downstream request. Make sure that the downstream request bit is in the off state. That would be input 5. Now that all three conveyors are full, what will happen when another arrives at Pt1? Well, to simulate this, turn on Pt1, leave it on and look at the conveyor routine. Of course, nothing is running because everyone's full, there's no place to go. What we have is a standoff. We have a part at the entrance of the conveyor buffer system. The system is full and manufacturing downstream is not calling for parts or objects. This is exactly what we want it to do. Wait for a request. When the request comes and conveyors start running, parts are going to move in front of Pe2, Pe3, and eventually, as they keep traveling, clear Pe1 onto conveyor 1, clear Pe2, clear Pe3, and so on, until they block and clear Pe4. You will operate the switches in this order, Pe1, 2, and 3 on in that order, and then Pe4. Look at the conveyors to see which are running. The conveyors running and clearing photo-wise will be in this order. 1 off, 2 off, 3 off, and then eventually 4 off. This simulates the parts blocking and clearing the photo-wise in that order. Pe1, 2, 3, 4, and then not Pe1, not 2, not 3, and not 4. Think this through carefully before you start. Visualize what you are doing. While observing the conveyor's routine, toggle the part request bit to the on state and leave it on. Okay, now it's on right now, that's bit 5, so I'll turn that off. And I'm going to look at production. 3, 3, and 1. Our conveyors are all full. Done, done, and done. 1, 2, 3. They're all done, they're all full. So now we turn on something at Pe1, but nothing moves. We do a downstream request. It's going to call for cartons. So we're going to turn on Pe2, 3, and then eventually the downstream, the exit. So we go back to production. They're all running, they're all debounced, so we do them in the opposite direction. 1, 2, 3, 4. So see, we're back to 3, 3, and 1, and we have one that's gone off the end of the conveyor. Now, it didn't work perfectly. There is a problem with this code. I kind of skimmed over it. If you saw it, excellent. You're ahead of the curve. You get an A. Course is all done. Go out and treat yourself to a good steak dinner or whatever flips your switch. Okay, there is a problem. Actually, there's several problems. If Pe1 clears first, all the conveyors stop. This is your first chance to experience debug commissioning firsthand. Hint, we want each conveyor to continue running if its entrance PE is blocked. We don't have that right now. If we look at the conveyors, we want that motor to continue running as long as this block, meaning if the circumstances were there to start the motor conveyor, we want to continue until we've completely pulled the carton through the photo eye. With conveyor 1, it is not a problem, but what condition are we missing in the logic for 2 and 3? What condition do we want to OR around with it? You would be doing yourself a great service to repeat this entire sequence from step 1, observing each change in the state of the logic. This is the essence of PLC programming: process visualization and writing the logic while you are visualizing the flow in your head. Remember, you don't have the machine to run it on, because the way this is set up, our little virtual project, it's not going to work right when you get out there and download it onto the conveyors. And if you're thinking, oh, it should, why are we doing one that's not going to work right? Because I'll guarantee you, you will never write a program of any size, go out and download it into the controller and have everything be exactly right from the beginning, not making any edits or changes. If you do, please give yourself a week off and celebrate or something. I've never known anyone to have that happen. There's always something that you overlook. Now, there is one caveat here. If you're burning up a lot of hours overthinking this, overanalyzing, and doing factory acceptance testing on simple machines to make sure the logic is absolutely perfect before you download it, you're spending too much money. You'll never be able to compete with other companies that do like an 85, 90, 95% correct code, download it into the machine, careful not to break anything, and then tweak it as they go and tidy up whatever bits need to be tidied up. Did make some changes. I'm going to make those changes and then come back. Here's what we did to tidy up the problem. And I will run some cartons through here very quickly to show you that it's been dealt with. Notice what we did is we added Photo I Conveyor 1 entrance in parallel with Photo I2 and Photo I3 because we want a carton arriving at Photo I1 to trigger the whole sequence. I'm going to go to production, and you can see I've got 3, 3, and 1. They're full. And I could go through and do calling downstream. As a matter of fact, I'm going to turn this off so it doesn't do it. Oop. I keep thinking that's an internal bit. It's not. It's a switch, so it's turned off. And for production, I'm going to reset all the conveyor counts and go back to the conveyor motors. Now this becomes more sequence critical with your toggle switches or your push buttons. And because I don't have, well, let me show you a way to be able to look somewhat at production and conveyors at the same time. So I'm going to go up to the top, I'm going to drag down a new rung, and I'm going to put in, I could put the done bits to show they're full. Instead, I'll be more clever and put in compare, and I'll do equals. So I'm going to say, let's go look at how these are named. Production, conveyor 1 count. Okay, back to conveyors. Conveyor 1, drill down, count. Do the accumulate. And we'll do the preset. So we'll drag that down to here. Double click. Backspace 3 times. Preset. This instruction says if the counter, the cum equals the preset, then this instruction would be true. But we're not going to do any true false business here. So I'm going to Control C, Control V, V. Okay, so I'm going to change this to 2. Change this to 2, change this to 3, change this to 3. And then after this, I'm going to do a no-op. And unfortunately, I can't remember. Move, file miscellaneous. Let's drag this puppy out so I can see, is it special? It's something I never use, no-op right there. So I want a no-op right there, no operation. This rung doesn't do anything. True or false, it does nothing, no operation. Now you see what I have. I have the accumulate and the preset that I can look at. If I want to make this even more, have more clarity, I can put in a done bit. Change that to 2. Change that to 3. That's as wide as I can make it, so I'm going to have to ungeezer it just a little. And finalize all edits. Okay, now there's our 3 conveyor rungs. And here's the state of our count. So it's kind of like a little HMI. But let's do photo I, entrance 1. See, there's nothing in the accumulate. I let go. Now you see over here there's 1. Hold it down till it times out. 2. Hold it down till it times out the debounce. 3. Now you see the done bit comes on. Okay, now if I back this up to 2, just to make a point, and if I push input 1, see the motor does come on. Now conveyor 2 does come on too. You know why? Because I knocked the accumulate, I knocked the preset down to 2, not the accumulate, and I didn't change the done bit. So I hosed all that. So I'm going to start over. I'll go back to production, reset the counts, and profusely apologize for doing the wrong thing. This wasn't in the manual. That's what happens when you run off doing stuff half-cocked. You don't rehearse it and look it over close. So let's try that again. We have 0 cartons in the system. Everything's reset. So photo I1, motor 1 comes on. Counts up to 1. The accumulate's on the top. That's what messed me up. I changed this instead of the accumulate. Okay, times out, motor's running. Now we got 2. Another carton arrives, times out, motor's running, moves it, clears the photo I. Now the next time I do this, I'm going to have to not use the push buttons, I have to use the toggle switch. So I turn on the toggle switch, there's a carton here. It starts motor 2. The carton on 1 moves onto conveyor 2, blocks that photo I. Clears 1, clears 2. Okay, see now I got 3 and 1. Let's do that again. Another carton arrives at 1, 2 comes on, comes into photo I 2, clears 1, clears 2. Now you see I've got 3 and 2. Another carton arrives at the entrance of 1, both motors come on, 1 and 2. Photo I2 is now blocked. 1 clears, then 2 clears. Now you see I have 3 and 3. Both counts are done. Both conveyors are full. Next time, I'm going to turn on 1. Now look, all 3 motors come on because conveyor 3 is not full. Then it moves into 2, moves into 3. Then 1 clears, 2 clears, 3 clears. So see I have 3, 3, and 1. And again, you may have noticed this went to 4 because we took our time counting on and off of the conveyors. But the end result is correct. Okay, at this point, if I turn on conveyor 1, nothing happens. They're full, and we're not calling for a downstream request. I'm going to turn on the downstream request. All the conveyors start to run. We have one blocking 1 already. We block 2, then 3, then eventually 4. That's the exit. Then we clear 1, clear 2, clear 3, clear 4. And see, we're back to 3, 3, and 1. There you go, folks. So the buffering system is driven primarily by cartons arriving at photo I1. Whether or not each conveyor is full, PE 2, 3, and 4 are used to count cartons on and off of each conveyor. Now, this is one solution. Thank you for your patience in sticking to the instructions in this manual, because we got a little loose here at the end, and if you need to go back and do the challenges again, revisit sections in the manual, that would be good. Okay, bonus challenge 1. Change the tags for each of the photo eyes to a base tag. Create a new subroutine called Factory Acceptance Test and the JSR in the main routine, and write logic to simulate the sequence of photo eyes as each new object arrives at the entrance of the first conveyor. Use 1 push button to announce a new object and have Pt1 clear the announcement. Have fun. I always do. If you need a hint on how to do that code, remember the code that we did where we simulated turning on switches and then having them self-extinguish? If you stick to this, if you start doing this bonus challenge, I'll guarantee you'll get it. I may do it myself and post it on YouTube. Thank you for watching.